Okay, I'm on page 863 in your textbook, section 14.5, and it says modeling circular motion. A Ferris wheel with a radius of 25 feet is rotating at a rate of 3 revolutions per minute. When t equals 0, a chair starts at the lowest point on the wheel, which is 5 feet above the ground. Write a model for the height h in feet of the chair as a function of the time t in seconds. Let me do a drawing and help figure this out a little bit. Ferris wheel with a rate of, I'm drawing its radius in here, with a radius of 25 feet. Is rotating 3 revolutions per minute, or 1 revolution every 20 seconds. 3 revolutions per minute. 1 revolution equals 1 period. So the period is 20 seconds. And the next thing says when t is 0, the chair starts at the lowest point on the wheel, 5 feet above the ground. So here's the starting point, and we are 5 feet above the ground. So up here, how high above the ground are we? 55 feet. So we want to model for the height as a function of time. So after, now since the period is 20 seconds, basically after 5 seconds it's here, 10 seconds, 15 seconds, 20 seconds. Now, both the sine function and the cosine function are possible candidates for this. Neither one starts here. So neither one starts at a negative, but since they're asking us the height of the chair, height is y, so it might be easier, I'm thinking it's easier to use the sine function. Y equals a sine bx. Again, we're only talking about height, we're not talking about left, right, so I'm not going to have an h, but I am going to have a k. Now, how's it going? All right. All right. Distractions just like in your real class. Great. Now, y equals a sine bx plus k. So if there was an h, it would be in parentheses, but there is no h. So the k is being added separately from this. And what do we know? We know the amplitude. The amplitude is 25. So y equals 25. And we know the period. And we know the k also. That's pretty easy. 25. One thing that might have to change, maybe we will need to use some h because the sine function does not start here, right? The sine function starts here. But we're going back here. So it's like negative. We really want negative this much. Negative this much. Okay, before we try to think about that, let's think about what the period is. Period is 20. So in our sine functions that we write out, period is 2 pi over b. So we need 2 pi over b to equal 20. To make 2 pi divided by what is 20? Well, first of all, we need to divide out the pi, then we need to actually multiply by 10. So to multiply by 10, we need b to be 1/10. 2 divided by 1/10 is 20. So b's got to be 1/10, but it also has to have a pi in it, so b has to be pi over 10. If that seemed like a lot, just click backward a few seconds and listen to what I just said again, because I don't think I can say it better than that. Sine pi over 10 x but is it x? Because really, we don't want sine of x would put us right here. I mean, if we plug in 0, that would put us right here, right? And we want to be back over here. We want to go all the way back here. So we're going back in time, I think 5 seconds. So let's say minus 5. If this is, and if you're listening to this, that means it's right. And I'm about to check it because I feel like I'm not sure that it is. And if it's wrong, I'm probably going to delete this video. And if you're watching it and it's wrong, well, I don't know what to tell you. Seems like it's wrong. For 2 reasons. One is, it's not plus 5. What is it? It's not plus 5. It's not plus 5. It's plus 30. Now, I wonder if there's another reason, because your book's using cosine. So is this function legitimate, or that I came up with, or is it just wrong? So let's look at what your book uses cosine. So let's go on another page and see what, if we wanted to do cosine. I wonder if I can screen cap this and bring it onto the next page. You have to put, I'm just going to dodge the out of the picture. And then we'll go on the next page. We'll bring in the picture. All those screenshots, Mr. Dittmer. Ah. All right, get that sort of off to the side. But then, all right, so now we want to use cosine. Again, clearly the 25 is still going to be 25. The period will also still be the period. But if we're using cosine, I guess the advantage in using cosine is cosine starts at 1, then becomes 0, then becomes -1, then becomes 0. Here we're starting at -1, becoming 0, becoming 1, becoming 0, so it's just the opposite of cosine. So you can make it negative cosine, and it should model, and then we don't need an x minus 5. And then we just have plus 30. Okay, so that the question then is, are these two equations the same? Let's find out. So the first equation is -25 cosine pi over 10. Oh, dang it, that's hard. How do I want, okay, find the cosine of pi over 10 times x plus 30. I'm going to zoom out. What the heck? Y equals -25 times cosine pi over 10x. What if I just put pi x over 10? There we go. That's what I wanted. Pi over 10x plus 30. All right, then the second graph is y equals 25 sine, basically this, but I said -5. Is that what we said? -5, right? Right? Wrong. Good try, Dittmer, but wrong. So why? See, my mistake was based on an identity that kind of makes sense. So let's sort of make errors here so we can clear the page. and explain the identities that kind of make sense here. So sine x equals cos x, sine x minus, I think it's pi over 2, should equal cos x. Does it have to, is it plus pi over 2? Yep, there it is. Sine x plus pi over 2 equals cos x. And so maybe this is what I needed to put up here to make it work. We can see maybe it's just there they are. Plus pi over 2. Not even, right? Not even close. What if it's plus 5? So I did minus 5. That seems close, but not quite identical. Oof. You can see how much it looks like it's off by. This is x is about negative 10.915, 10 even. Pi over 4? No. Well, this is right, this is wrong. But why? Why is this wrong? And if you don't care, understandably, you might want to stop this video. I'll start a new video if I've got something good to say, but I'm just exploring. So the sine function gives me, I mean, to check that this one's right, double check that, sorry, that this one's right, you can plug something in. So you can plug in 0, and the cosine of 0 is 1. So when you plug, so you get 1 right here. Negative 25 times 1 is negative 25, plus 30 is 5. And indeed, when you plug in 0, you want to be at 5 to be your output. Plug in 0 seconds, you get 5 feet. Then you plug in 5 seconds, you want to be at 30 feet. So if you plug in 5 seconds, plug in 5 for, oh, I forgot x. How embarrassing. Plug in 5 seconds here, I get 5 pi over 10. That's pi over 2. Cosine of pi over 2 is 0. That means this whole thing is 0 plus 30, 30. So that's what I wanted. I wanted 30. After 10 seconds, I want to be at 55 feet. So plug in 10 here. 10 pi over 10 is pi. Cosine of pi is negative 1. Negative 25 times negative 1 is 25. 25 plus 30 is 55. And at 15 seconds, I want to be at back at 30. Plug in 15. I get 15 pi over 10. That's 3 pi over 2. Cosine of 3 pi over 2 is 0. That means this whole thing is 0, and I'm back at 30. That works. So what am I going to do to make the sine function work? Well, sine pi, so I plug in 0, I want to get, I'm going to pause this because I plug in 0, I want to get 5. If I plug in 0 to this, I'll get, if I don't have the minus 5 here, and I plug in 0, then I'll be looking at sine 0 is 0, and I'll get 30. I don't want 30, I want, so how do I get a sine function? I want to find the sine of that thing that is negative 1. So the sine of what is negative 1? The sine of 3 pi over 2 is negative 1. So I need my sine function to somehow go be 3, this thing to be here to be 3 pi over 2. I was messing with it in another color, but sometimes you got to accept you're going to run out of time, you're not going to finish the problem. Stay tuned for the next video where I finish the problem.